going in to talk him off the ledge?
Madam Mercy, can you hear me? Madam Mercy?
Great. Most of us have the correct issue.
I was saying that we continue with the lesson for the remaining minutes. I just want to hope that you can all hear me. For the remaining minutes, we shall see what we can do. We had some technicalities, but I believe that the minutes that are remaining, we shall learn a lot. We shall learn a lot. And so that is exactly what I will do. I may not be able to share so much on the screen for now. And so I would want us to go straight to the questions that you had been given for the assignment. And you have gone through the questions, I believe, for those days that you have been at home. You have gone through those questions. And so mine would just affirming the answers that you have written, because I believe you have got some answers that you have written. The first question on that assignment was asking on hydrogen chloride gas. From the topic chlorine and its compound, one of the gases that is discussed there is hydrogen chloride gas. And in the first question, it was asking about how the gas is put in water or dissolved in water. It is one of the 3 highly soluble gases. And highly soluble gases are dissolved in water by connecting an inverted funnel at the delivery tube that is getting to the water trough. And the reason for doing that, of course, is to increase the surface area so that we have a large area to allow the gas to interact with the water. And that is the use of the funnel, to increase the surface area for the absorption of the gas. The other reason why an inverted funnel is used, it is to prevent the sucking back of the water, because the gas is highly soluble in water. So if there is not enough space, the water will tend to get inside the funnel. So that is the other reason, to avoid the sucking back of the water into the delivery tube. The other question was on how, when that gas is put in water, what is formed? Definitely, when water is put on a gas that is soluble, it will form an aqueous solution. An aqueous solution is formed when a solute, either solid or liquid, is put in water, and the solute or the solvent is able to interact with water. Because water is polar, and meaning that it has got both positively charged ions, that is a hydrogen, and the negatively charged oxygen. So it is able now to attract any positive or negative charged solvent or solute. For that case, then the hydrogen ions in the water will tend to get attracted to the chloride ions of the hydrogen gas, and the oxygen that is negatively charged will tend to attract to the positively charged hydrogen of the hydrogen chloride. That way, then the bond between the hydrogen and the chloride will break, and so hydrogen chloride ion or ionic solution will be formed. So in that case, hydrogen now will be ion. And when we have hydrogen ions in the water, that is an acidic solution. What is an acid? A substance that when dissolved in water gives hydrogen ions as the only positive ions. So now that solution is said to be acidic because it has got hydrogen ions from the hydrogen chloride gas solution. All right. That was just a short break. For this particular lesson, the way it seems, we are not able to maybe to interact so much, but I want to believe that now because it is breathing, because we cannot really communicate, but I want to believe that we can make it the way it is for now. Then the other one will be able to deal with some of the technicalities, because learning should be two-way, so that at one point you are also able to participate. At one point, you're also able to ask questions, to interact. We make it a discussion. So I will just go through. I'll just go through the questions. The second question that we had.
Madam Mercy, may you please repeat the part where can you give a definite answer towards question 1A?
Okay, thank you very much. I'm speaking with who?
Kingston Uhuru.
Nani?
Kingston.
Yeah. So you can hear me, and you are able to speak to me, eh?
Yeah.
Okay. Now read the question for me, please.
Okay.
And I thank you very much. Thank you very much.
So question 1A, when a blue litmus paper was dropped into the resulting solution, it turned red. Give a reason for this observation. So what's
Yeah.
the correct way to explain it?
Yes, Kingston, thank you very much. At least now I'm happy that I can I have audience. I'm able to tell that you are hearing what I'm saying. When the hydrogen
Yeah.
chloride gas, I said it form an acidic solution. So why is the blue litmus paper changing to red? Because there are hydrogen ions in the solution. Because now the hydrogen chloride gas in water, it is not in molecular form again. It is now in ionic form. We have hydrogen ions in the solution. We have chloride ions in the solution. So which ones are responsible for changing the blue litmus paper to red? The hydrogen ions. Have I answered it the way that
Yes.
I've answered your question? Right. And thank you. Let's keep talking so that we have an interactive lesson. Thank you very much. Now I
Welcome.
can proceed. Yes, I can. The one for the inverted funnel is well understood. Eh?
Yeah.
Right. Thank you. Please keep on talking so that we can have a good lesson. Now we move to the other question on the chlorofluorocarbons. We move to that question about chlorofluorocarbons. That chlorofluorocarbons are synthetic compounds containing, from the word chloro, containing chlorine and carbon. So those are the three atoms that make that compound. It is a synthetic compound, meaning that it is a compound that is made in the laboratory, of course. It is an inorganic compound. And formerly called the CFCs. And they are also referred to as freons. And they have got so many uses. One of them is that they are used in making aerosol sprays. They are also used as blowing agents to form foam, or foam like sabuni. They are also used in making solvents and also refrigerants. But nowadays, they are not very popular because in the year 1996, they were banned. For what reason? Because they had, or they normally have a negative effect to the environment. The fact that they deplete the ozone layer, which is a very useful layer that is meant to protect us from the harmful ultraviolet rays from the sunlight. So the CFCs nowadays, they are not very popular. They are not commonly used because of that reason. And going with the question, then I have defined what they are. So the other question was, what are their negative effects? And I have said their negative effect is that they are not commonly used because they deplete the ozone layer, which is meant to protect us from, or to protect the earth from the harmful ultraviolet rays from the sun. How do they affect the ozone layer? Once they are released in the environment, that is the CFCs, and they rise into the stratosphere, they are broken down by strong ultraviolet radiation that is released from they release chlorine atoms or fluorine atoms. Now the fluorine atom or the chlorine atom, because we know halogens are very reactive, now they are the ones that react with the ozone, the O3, and they form the fluorine oxide or the chlorine oxide plus oxygen gas. So that way the O3 is destroyed because it is broken down to an oxygen atom and oxygen gas. So for that reason, CFCs are not recommended for any use, whether as aerosol spray, whether as solvent, or whether as refrigerant, because they destroy the ozone.
Excuse me, madam.
Yes, Kingston.
The part where you said that they destroy the ozone layer, you said, okay, which compound is responsible for depleting the oxygen into oxygen gas and oxygen atoms?
I have said the CFC compound.
Huh?
Of course, when they rise up there, they are broken down by the ultraviolet radiation. They are broken down. The CFC compound is broken down by the ultraviolet radiation. So we start by breaking the CFC down by what? By the ultraviolet radiation. Such that now we have carbon alone, fluorine alone, like that, and chlorine alone. Now those chlorine and fluorine atoms now are the ones that are reactive, because we know halogens are reactive. Those atoms of either chlorine or fluorine, they react with the O3. And now the O3, that is how it is broken down, because now you form chlorine plus O3, you get ClO plus O2. In that equation, in that equation, you see now the O3 has been broken down to what? To
Chlorate
O2
and chlorate, ClO.
Chlorine oxide or fluorine oxide plus oxygen gas. So from that reaction, now you see there is no longer the O3 in the atmosphere. Is that part clear?
Yeah.
What are we looking on? We are looking on how the CFCs destroy the ozone layer that is meant to protect us from, or to protect the earth from the harmful ultraviolet radiation from the sun. Ni sawa, eh?
Yeah, it's okay. Thank you. I need to just start for a bit. I might equal.
Now we move next to the next is somebody to add something or to ask a question. On the chlorofluorocarbons and their effect to the environment. Any other
Chair,
question on this? Yes.
what is the effect of dichlorodiphenyl trichloroethane?
Dichloro.
Diphenyl,
Mm-hmm.
yeah,
Oh,
trichloroethane.
that is the DDT, eh?
Yeah.
That is the short form of the DDT, eh? That one, once it used to be used as a pesticide, but I've said
Yeah.
both of them, it has been banned. Nowadays, it is not used. Reason, it is because when it is put into the, when it is released into the soil, or when it is released in the environment, it forms non-biodegradable compounds, or it is not easily decomposed. For that reason, now it becomes a pollutant. And its decomposition even take years for it to be broken down. So such a compound is banned from use. Reason will be a pollutant. So for that reason, that is its effect, that it does not decompose, or it is not decomposed by microorganisms, the normal biological decomposition, and so it is no longer used as a pesticide. It was also banned because of that effect of pollution.
Okay, thank you.
Right. Do we have other people in the group hearing me who can also respond or interact with the teacher? Are they there? Please, they tell me they can hear me. We can continue. The other question was a question on chlorine reacting with hydrogen sulfide, that diagram. And the two are able to react to form hydrogen chloride gas and sulfur. Hydrogen sulfide plus chlorine, the product is hydrogen chloride gas plus sulfur.
Solid.
Sulfur is solid. And let us write that question and balance. I give you a minute to write and balance the equation.
Chair.
I've said we write the question and balance.
I've already balanced.
Okay, I give others maybe a minute, because I see the class, it's only Kingston who is able to talk to me. Maybe the others are not able, but we can give them, because they can hear me, we give them a minute to balance. Now we can check the equation. Hydrogen sulfide, H2S is a gas, plus Cl2, chlorine, which is also a gas, and the product would be hydrogen chloride gas. In front of it, we put a 2, so that we can have 2 hydrogen and 2 chlorine, just like on the reactant side, then plus sulfur. In that equation, what is the product? The product is hydrogen chloride gas and sulfur. What are the observations? Observation is based on what was the color before the reaction. And then after the reaction, what are the changes of the color or the state of matter? We can start with color. The reactants are 1, hydrogen chloride gas, which is a colorless gas, and chlorine gas, which is a green-yellow gas. And what are the products? A colorless hydrogen chloride gas and a yellow
Ndiye
yellow
ananiitwa
solid.
moja bidhaa ama
For
yeye
that
ako
case,
unmuted system throughout.
for that case, the observation would be a yellow solid, which is
Sorry,
sulfur.
is
Excuse
A
me, Chair.
yellow, yes.
Please,
Who
can you
is
repeat the
speaking?
question? Tim Collins.
Yes. The question is reacting hydrogen chloride, hydrogen sulfide, and chlorine gas. Hydrogen sulfide gas, how does it react with the chlorine? That is the equation we are writing.
Thank you.
Excuse, teacher.
Yes.
On the point of ions, you had explained before that hydrogen ions are what give the acidic properties of, say, like a substance. So when on the reaction, when you have hydrogen, the reaction of using acidified potassium manganate 7, what is the reason of acidifying it? To give it the ionic, the acidic properties, or to distinguish the ions?
Now that question is which one, so that we don't get mixed up. Let me first of all finish, and then because there is that question of preparing chlorine, hiyo sijasomesha. Hiyo iko hapo chini, the one for preparing chlorine. Your question is that, si ndio? We are first of all dealing with the reaction of hydrogen sulfide and chlorine. So that now we trickle down, we go now to the other question on preparing chlorine. We first of all finish the one for hydrogen sulfide and chlorine. Allow me to finish it, and then we can handle the other question. Hydrogen sulfide, when reacted with chlorine, I was saying that the product will be hydrogen chloride gas and sulfur, which is a yellow solid. And I was answering with what question? What are the products? The products are hydrogen chloride and sulfur. What is the observation? A yellow solid is formed. And in that reaction, chlorine is the oxidizing agent. It oxidizes hydrogen sulfide to sulfur. So there we are able to see that the hydrogen sulfide has been oxidized to sulfur. And the chlorine gas, which is an oxidizing agent, is reduced from chlorine molecule, that is chlorine atom, to chloride ions. That is reduction. Now I can move from that question. I go to the other question. so that I reach to the one of acidifying. The other question is, what happens when chlorine is put in water? Chlorine gas is a soluble gas, and when it is put in water, it will form two acids, the chloric 1 acid and hydrochloric acid. Writing that equation, chlorine plus water, Cl2 plus H2O, the products are HOCl, which can also be written as HClO plus HCl. And the equation is balanced. Then the other question that follows there is, how does chlorine breaches? It breaches by oxidation. And the chloric 1 acid, the HOCl, the HClO, is the one that is the breaching agent. Reason, when it is exposed to sunlight, it easily decomposes to form the hydrochloric acid and oxygen. And that oxygen that is released when it decomposes, it's the one that is added to the colored dye, and it makes the colored dye to be decolorized. Therefore, the combination of the colored dye and oxygen will form a decolorized dye. And of course, the other product will be the HCl. So that is oxidation, because the colored dye is added oxygen, and when it is added oxygen, it becomes decolorized. So that is breaching by oxidation. Now, up to that point, now we can have any question regarding that part of chlorine. Any question regarding now chlorine? Now they can come up, the one we're asking.
Cha,
Mm-hmm.
question 3, where it stated, water from a town in Kenya is suspected to contain chloride ions, but not sulfate ion. Describe how the presence of the chloride ions in the water can be shown.
Chloride ions,
Yeah.
when they're in the solution, of course, that solution will be colorless, because when you have ions in the water, they are formed by soluble solutes or soluble solvents. So in that case, putting anything or putting any substance that will form precipitation, then will help us to know, indeed, the ions that are present are not sulfate, they are chloride ions. So we look for an insoluble chloride. And the insoluble chloride can be formed by putting a soluble salt like silver. So we can put silver nitrate to the chloride ions that are in the solution, and then we'll be able to see precipitation because of the formation of silver chloride. We can also use lead nitrate solution. It must be a solution, you see. Lead nitrate solution, which is colorless. And of course, where the chloride ions are, is also a colorless solution. So now when you put the red nitrate, then the chloride ions in the water will interact with the lead and form lead chloride, and white precipitation will be seen. So the white precipitate now will indicate that in the solution, there are chloride ions, because the lead chloride is an insoluble chloride. The silver chloride is an insoluble chloride. So basically, adding either silver nitrate or lead nitrate to the solution that is suspected to contain chloride ions.
Okay, Cha, let's take, for example, calcium. Okay, if I were to put, let's say, calcium carbonate into the water sample, it will not form any precipitate.
In ionic precipitation that we learned in book 2, ionic precipitation is done when you are having two soluble solutions, and calcium carbonate is not soluble, so it cannot be used, because here we are doing double decomposition, or we are doing ionic precipitation. In ionic precipitation, you put a soluble salt, the way I have given an example of silver nitrate is soluble.
And
where the
lead
chloride
nitrate.
ions are, where the chloride ions are, it is also soluble, or rather it was a soluble solution. So now we have two soluble solutions. And when the silver ions that are in the silver nitrate interact with the ions that are in the water, which are chloride ions, now a white precipitate is formed. So in that case, you use two solutions, two colorless solutions, two aqueous solutions to form one insoluble and one soluble. So calcium carbonate cannot be used.
Oh. Thank you.
There was another person there who had a question to do with the potassium nitrate. Potassium manganate 7. Okay. Let me continue with the other question that is there on preparation of chlorine, where manganese 4 oxide is being added to concentrated hydrochloric acid. And then the question asks, why is it that no gas is formed? If the gas was to be formed, then the manganese 4 oxide must be heated to provide energy to initiate the reaction. Manganese 4 oxide, to react with the hydrochloric acid, must be heated. So there is no heat, and so the reaction cannot take place. But if heat is put, the manganese 4 oxide will react with the concentrated hydrochloric acid to form a chloride. What chloride? Manganate chloride. The other products will be water and chlorine. The other products will be water and chlorine. For that reaction to take place, there must be heat. The other way the chlorine can also be prepared is using potassium manganate 7. There is a person who had mentioned that. Potassium manganate 7 with concentrated hydrochloric acid will not require heat. The reactants are able to initiate the reaction without necessarily heating them. So heat will not be required if it was potassium manganate 7. And so the products will be, from the potassium, we form potassium chloride. Then we have manganate there. So from the manganate, then we form manganate chloride. Of course, the other products will be chlorine and water. So the assignment will be balancing the two equations. That will be part of the assignment. And I'm just waiting to hear whether there is another person with a question regarding those questions that we are given on chlorine.
Cha,
Yes, that is who.
just a question. Kingston.
Who is that? Kingston.
King.
Kingston. This
Yeah?
lesson is like it is for me and you. There are not other people who are able to participate. Anyway, it's fine. But I wish we would
No,
have other people.
no, I'm just asking, are
Mm.
all precipitates white? Because in question 3, you said that when silver nitrate or lead nitrate reacts with the chloride ions in the sample in the water, it will form a precipitate.
That one will take us back to sorts in form
Good.
2. And
Yeah.
the colored, we only have the colored cation as iron 2, which is green, iron 3, which is brown, and copper, which is blue. Basically, the other salts that we use are white. When you put any white salt in water, it
So
will
the-
form a colorless solution.
Yeah.
I have said, when you put any white salt in water and it is soluble, it will form a colorless solution. A very practical example is the salt, the cooking salt, the salt that we add on food. If you put it in the food, the solution, the water remains colorless. So white salts, when they are put in water, they form colorless solutions if they are soluble. If they are soluble, their precipitate will be white. The colored salt, the colored ions like copper, 2 ions, when it is put in water and it is form a soluble salt like copper sulfate, the copper sulfate will be a blue solution. If it is iron 2, which is green, when it is soluble in water, it will form a green solution. If it is insoluble, like in the water, then it will form a green precipitate. Like iron 2 hydroxide, it is an insoluble solution. So it will form a green precipitate. Not all salts are white. Not all
So
salts are white.
So the only colored salts are any salts involving iron 2, iron 3, and copper.
Yes.
Okay. Thank you.
Yes.
I was asking about alternatives to CSC.
You said?
There are alternatives to the chlorofluorocarbons.
Your question is whether they are whether we have other substances that can be used instead of chlorofluorocarbons. Yes, like in the refrigeration, we will base other alternative on the uses. If it was to be used as a refrigerant, then we have got other substances that can be used as refrigerants that we have learned. Like we learned, we can use nitrogen. Nitrogen can be used. Ammonia can be used as a refrigerant. So basically, any other compound that can be used of the same use, but it doesn't have a lot of harm to the environment. Like in refrigeration, we can have nitrogen gas. It can be used in refrigeration. We can have ammonia in refrigeration. And so we can have other substances used to replace the chlorofluorocarbons, and they play the same effect. They play the same role.
Sure. Which
Kingston
other?
again.
You said the other substance. Are there any other substances that can be used in refrigerants apart from ammonia and nitrogen, or it's just those two?
Those are examples. Those two are the examples. I'm using the ones that we have learned in the topic of nitrogen and its compound.
Oh, okay.
Those ones we have learned them. I've used the ones that we already know from the
Yes.
topic of nitrogen and its compound.
Thank you.
The next one is I understand that maybe the others would want to participate, but maybe they are not able. They are not able. And I want to hope that they were listening, or they are listening and they are following. Of course, maybe all of us cannot be able to talk in a lesson like this one. But of importance is that you are following what we are doing. That is what that is important. That everybody who is in the lesson is following what I'm saying. And where you are doing the needful, even if the teacher is not seeing you. I want to believe that everybody is an active participant. You are an active participant. We can move to the other question. I don't know whether we have really exhausted the one of the chlorine, because that topic normally is a bit, it has got more than the questions that have been given there. But because we have touched on the preparation, and I gave assignment that is not there, the one that you can do after the lesson, you practice on how to balance those equations on the preparation of chlorine using potassium manganate 7, using manganese 4 oxide, using
And
lead 4
lead 4.
oxide. Yes. So that is the assignment, because writing and balancing equation is an assignment that is continuous. Even if you are not given any other assignment, writing and balancing equation is a continuous assignment. So that is the one I've given you. For the way to prepare chlorine, the 3 equations, write and balance them. I hope everybody has heard. Using manganese 4 oxide and hydrochloric acid, using potassium manganate 7 and hydrochloric acid, and using lead 4 oxide and hydrochloric acid. The other question that followed there is a question on the greenhouse gases. And greenhouse gases are gases that trap heat and warmth of the atmosphere. So they are able to trap the heat and the warmth that is being emitted from the biosphere. Those gases are, as we have been given there, some of them are carbon 4 oxide, methane, nitrous oxide. Nitrous oxide is the nitrogen 1 oxide, water vapor, trichloromethane are examples. We move to the question down there. What is the source of nitrogen 1 oxide? From the topic of nitrogen and its compound, us, we have run the very simple way of preparing nitrogen 1 oxide in the laboratory by decomposing ammonium nitrate. That is the way to prepare 3 little amount of nitrogen 1 oxide. Ammonium nitrate, when it is heated, nitrates decompose when they are heated to form nitrogen 1 oxide and water vapor. That is the laboratory preparation. But the nitrogen 1 oxide that is now found in the atmosphere, most of it is as a result of it got from the use of fertilizers, because we know that we use nitrogenous fertilizers in farming. That is in agriculture. We also have the emission of the gas from the transportation industry, because we know fuels, when fuel are burning, that is the motor fuel fuels, when they are burning in the engine, the nitrogen in the air is oxidized. And so that one can also be another source of forming the nitrogen 1 oxide that is found in the atmosphere. And basically, for the nitrogen 1 oxide, which is a greenhouse gas, the source is agriculture, transportation industry. Those are the sources. The other one, which is there, that is the trichloromethane. Trichloromethane is simply formed when you have methane, the CH4. CH4 is the methane. Methane, of course, we know it is got from the natural gas, biogas. That is the main, those are the sources. Although we also have methane got from the crude oil. The crude oil gives methane, the natural gas, the biogas. Those are the sources of methane. And when chlorine is reacted with the methane, all those hydrogen in the CH4, because it is CH4, are replaced by the chlorine. And then you form carbon that is bonded to 4 chlorine. And so we call it tetrachloromethane. Then, of course, the carbon 4 oxide is emitted from the, is put in the environment from the gaseous exchange of animals and also the combustion. Basically, fuels are carbon, and when carbon is burnt in air, it is oxidized to carbon 4 oxide. That is how the carbon 4 oxide is put into the atmosphere. To reduce the effect of the greenhouse gases, for the nitrogen 1 oxide, it can be reduced by using less nitrogenous fertilizers. It is also reduced by use of nitrification inhibitors to inhibit the formation of the nitrogen 1 oxide. And it can also be reduced by use of less nitrogenous fertilizers and use of split application of nitrogen fertilizers. That part of the greenhouse gases, I am seeing like we are done. Even in the syllabus, it is not given a lot of weight, but I've tried to emphasize a bit on the question because it is part of the assignment. Oh, no. Sasa sio mimi na